Graphing linear, non-proportional relationships using slope and y-intercept. Remember, we have the form y equals mx plus b. M represents the slope, b is the y-intercept. Remember, you can find the slope by doing the change in y over the change in x, which is y2 minus y1 over x2 minus x1. Or you can do rise over run. The b is the y-intercept, where it intersects the y-axis, or when x equals 0. Okay, let's take a look at example 1. We have y equals 2/3 x minus 1. So the slope is 2/3. The b is -1. I'm going to intersect the y-axis at -1, so you go down 1. The slope is rise over run, so you're going to go up 2 over 3. All right, so that's how we do example 1. Part B. The slope is -5/2. The y-intercept is 3. So we start at +3. This is counting by 2's. 2, 4, 6, 8, 10, 12. So in between 2 and 4 is 3. And then from here, we are going to go down 5 to the right 2. All right. Let's take a look at number 2. My slope is 1/2. My y-intercept is 1. So I'm going to start at 1. These are counting by 1s. 1, 2, 3, 4, 5, 6. So I start at 1. And I'm going to go up 1 over 2. Up 1 over 2. Up 1 over 2. And then I can connect the dots. That's one way you can do it. Also, if you wanted to do, you could do an input-output table where you had 1/2 x plus 1 and you could put in different numbers and so on. Okay, this is doing it graphically, and this is with substitution. You'll get the same answers. All right, so let's look at number 3. M is -3. The y-intercept is 4. All right, so we're going to start at 4. We're going by 1, so we're going to go down 3 to the right 1. 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. And we're going to connect the dots. Same thing, if you don't want to do it graphically, you can always do it with substitution, where you have an input-output table and plug in random numbers. Okay, flip it to the back side. On the back side, example 2, Karen has a weekly goal for the number of calories Ken has a weekly goal for the number of calories he will burn by taking brisk walks. The equation y equals negative 300x plus 2,400 represents the number of calories Ken has left to burn after x hours of walking. So what if Ken decides to modify his exercise plans from example 2 by slowing the speed at which he walks? The equation for the modified plan is y equals negative 200x plus 2,400. Okay, well in the first example, m is negative 300 and the slope is negative 300, the y-intercept is 2,400. In the second example, the slope is negative 200 and the y-intercept is still 2,400. Alright, so let's graph this. We're going to start at 2,400. So that's the y-intercept. These are going by 300. So let's say that I went by 600. So let's say I went down 600 and to the right 3. That would get me a slope of negative 200. So if I went down 600 and to the right 3, it would look like that. Okay, and then if I did that again, if I went down 600 to the right 3, okay, and if I went down 600 and to the right 3, and if I went down 600 and to the right 3, it would look like this. Okay, so then I would plot, connect my dots. How does the new equation compare with the equation in example 2? They have the same y-intercept. New slope is negative 200, not negative 300. Will Ken have to exercise more or less to meet his goal? Well, since his constant rate of change went down, he's going to have to exercise more. Ken will have to exercise more to burn more calories. Okay, suppose Ken decides that instead of walking, he will jog, and jogging burns 600 calories per hour. How do you think this will change the graph? This will change the graph by making the graph steeper. Well, the y-intercept will not change. But the slope will be steeper because he is burning more calories per hour.